In our super digital world, we're always looking for complex code and high-tech fixes for security. But what if the real answer to a trustworthy election system relied on something, well, a lot simpler? Something as basic as gravity. Today, we're going to take a look at the G2 election system and its totally fascinating physical approach to voting.
I mean, this is the ultimate puzzle in any election, right? How do you prove that every single vote gets counted, but without ever revealing who casts which vote? Well, the G2 system thinks it has a mechanical answer to this very digital problem. So I want you to forget everything you think you know about electronic voting machines. We're going back to basics here, but with a really clever modern twist. Okay, the big idea here is minimal moving parts. Instead of trusting complicated software that's, kind of hard to audit, this system uses physics that you can literally see with your own eyes. To really get how it works, let's follow one single paper ballot on its journey, right from the moment it's cast.
The absolute first step to making a vote fair is to break that link between the person voting and the piece of paper they're holding. And you have to do it right from the very start. So a voter doesn't just drop their ballot into one big box. Nope. They get to choose from one of several of these random vote drop slots right at the top of the machine. And that simple choice, that's the very first layer of anonymity. It immediately makes it unclear which ballot belongs to the person who just walked away. It really is a beautifully simple process. The voter's choice of slot, totally random. Once it's dropped, the ballot just slides down into its own little collection tray. And just like that, it's physically separate from the voter, and it's now sitting with a small, anonymous group of other ballots. Okay, and this is where things get really ingenious. That first little step is just the beginning. Now we get to the core of the whole system, a physical shuffle that basically guarantees anonymity. So you gotta understand this key idea: paper batch consolidation. The system never, ever deals with just one ballot at a time. It's all about collecting them in these small, random, anonymous batches, getting them ready for the big mix. See how these slot hourly collection trays are tilted? That lets the ballots just slide in and pile up. And each tray is designed to hold on to them until a specific trigger is met. That could be when enough ballots pile up to hit a certain weight, or it could just be after a set amount of time, like an hour, has passed. And this right here, this is the whole philosophy of the system in a nutshell. There's no complex sensor, no lines of code deciding when to release the ballots. It's just simple, verifiable physics. The weight of the paper itself is literally part of the mechanism. How cool is that? This is the magic moment. This is the vote shuffle. As soon as that trigger is hit, a simple paper stopper opens up and whoosh, the whole batch of ballots just tumbles down, mixing in with batches from all the other slots into that bigger hourly vote consolidation tray. It's just a really elegant physical shuffle. So, our little ballot's journey to anonymity is almost finished. Now it just needs to become part of the public count, all without ever giving away where it came from. And here's the result. All those small batches from the different slots have now merged into one big, mixed-up, consolidated group. I mean, at this point, it is physically impossible to trace any single ballot back to its original drop slot, let alone to the actual voter. Now, this whole process of consolidating and releasing isn't random. Nope. It happens on a really regular, predictable schedule. In this particular design, it's every single hour. That predictable timing is key because it ensures there's a steady, transparent flow of results that anyone can watch all day long. And finally, the entire consolidated batch is released to be counted, and the results are added to this votes display grid. So the public sees the vote counts update on the hour, but all they ever see is the new grand total. The individual ballot? It's been successfully counted, and its journey is completely anonymous. So you might be asking, why go through all this mechanical trouble with chutes and trays and gravity when we have microchips? Well, it all comes down to two very important words: transparency and trust. So let's just recap the big advantages here. First off, the system physically severs the link between you and your ballot. It does it with observable physics, not some hidden code you can't see. This creates a completely transparent and auditable paper trail. And because of its simple, minimal moving parts design, it's incredibly reliable. It's security you can actually see. And that really leaves us with a fascinating final thought. In our endless search for more and more complex digital security, maybe, just maybe, we've overlooked the power and the inherent trustworthiness of elegant, simple, physical solutions. What do you think?